This video will introduce you to the law of sines and cosines. The trigonometric ratios of sine, cosine, and tangent are all important when you want to solve for missing angles or sides of a right triangle. But what about the triangle that is not right? These are called oblique triangles. Unfortunately, the ratios that worked for right triangles do not work for oblique triangles. Luckily, you can still use trigonometry to solve the triangle, but you need to use different formulas. The first formula is called the law of sines. The law of sines tells you that the ratios of a triangle's side over the sine of its opposite angle are all the same. In other words, the length of side A over the sine of angle A is equal to the length of side B over the sine of angle B, which is equal to the length of side C over the sine of angle C. The law of sines works for all triangles, even right triangles. You can use the law of sines when you have enough information to fill in 3 out of the 4 parts of the ratio. Try the following problem. Find the length of side AB. Find a proportion where you have enough information for both a side length and the angle opposite that side. To solve using the law of sines, you only need 2 sets of fractions from the equation. Plug the first set of numbers in, and then figure out your next set of numbers. You want to find the length of side AB. So to complete the proportion, you will also need the angle opposite that side. Plug this information into the second equation. To solve, cross-multiply, simplify, get AB by itself, and solve to find that the length of AB is 80.3. Let's try another problem. Find all the missing angles and sides of the triangle. Do you have enough information? You need values for at least one side and its opposite angle. Looking at the triangle, you have the length of one side, but not its opposite angle. But you can find the measure of the opposite angle, right? Since it's the only missing angle in the triangle, you can find it by subtracting the sum of the other 2 angles from 180. So the missing angle is 24 degrees. Now you have enough information to use the law of sines. Since you only have one side length, the first ratio will be 22 over the sine of 24. Then set up the remaining ratios. So this equals QR over the sine of 100, which equals QP over the sine of 56. To solve for QR, cross-multiply, simplify, get QR by itself, and solve to find that QR is 53.4. You have now found the missing angle and one missing side. To find the last missing side, you can cross-multiply again. To solve for QP, cross-multiply, simplify, get QP by itself, and solve to find that QP is 45. You have now found the missing angles and sides of the triangle. How about this triangle? Can you find the missing angles and sides? You can't use SOHCAHTOA or the Pythagorean theorem because it's not a right triangle. And you can't use the law of sines because you don't have a side length and its opposite angle to use a ratio. You can, however, use an equation called the law of cosines. The law of cosines tells you that the square of a side of a triangle is equal to the sum of the squares of the other 2 sides minus 2 times the length of those sides times the cosine of the angle opposite. There are 3 formulas for the law of cosines, 1 to represent each side. The law of cosines looks a lot like the Pythagorean theorem, doesn't it? Let's take a look at the proof of the law of cosines and why it works. The first step to proving the law of cosines is to create a right triangle so that you can start with the Pythagorean theorem. To do this, draw an altitude with height h and call the 2 new segments of side C x and C minus x. Note that b squared, which is the hypotenuse of the smaller right triangle, equals x squared plus h squared by the Pythagorean theorem. And cosine of A is equal to the adjacent over the hypotenuse, which is x over b. This can be rewritten as x is equal to b times cosine of a. For the bigger triangle, you can use the Pythagorean theorem to write that a squared is equal to c minus x squared plus h squared. Expand c minus x squared to get c squared minus 2cx plus x squared, and rewrite the equation. Looking at the whole equation, you can't simplify anything, but you can substitute a number of things in. Looking back to the first step, x squared plus h squared is equal to b squared. You also have x squared plus h squared in this last step, so substitute that with b squared. Also, since x is equal to b cosine of a, you can substitute b cosine of a in for x. Rewrite what you have, and use the commutative property to move b squared to the front of the equation and switch c times b. You are then left with the law of cosines. This proof showed the proof for one of the equations. The other two can be done in the same way. Try the following problem. Find the length of xy. Since the triangle is obtuse, you can't use SOHCAHTOA or the Pythagorean theorem. And since you don't have a side and opposite angle pair, you can't use the law of sines. So let's try the law of cosines. Notice in the equation that the one angle that you have matches the opposite side that you are solving for. In your triangle, the side you are looking for is opposite the angle you are given. So these will be your A in the equation. So the angle is 36. What about B and C? B and C are the other two lengths of the triangle. It doesn't matter which one you assign to which, but for our sake, let's call B 8 and C 12. Rewrite the equation with the given information. Simplify everything on the right-hand side of the equation. To get a squared is equal to 52.7. Take the square root of both sides. To get that a is equal to 7.3. So the length of xy is 7.3. In review, when you have an oblique triangle, you can use the law of sines or the law of cosines to solve for the missing angles and sides. Happy solving!